the screen. First one is your scalability, ability to deal with the different type of attributes, discovery of cluster with arbitrary shape, domain knowledge is also required, able to deal with the noisy or any kind of erroneous data, capability to deal with the multi-dimensional data, interpretability and usability. So these are the requirements when we are developing any cluster technique. So these are certain requirements that we will consider, that we will be keeping into our mind when designing any clustering technique, right? Now, what are the criteria based on which certain clustering techniques are divided? First is a partitioning criteria, how you are going to separate the cluster, which distance matrix you are using, and what is the space. You are creating a cluster in the 2D space or in the 3D space, right? So what going to separate the cluster, what is the similarity measure, means what are the distance measure that you are going to use by developing a clustering technique, and are you developing a clustering method for the 2D space or the 3D space. So these are the certain criteria that you need to also consider while designing the algorithm, or while doing the comparative analysis of the multiple clustering technique, right? Now, this is an example of a data set. Here the objects are grouped, one group, two group, three groups. So how you are going to design the algorithm for finding out there are how many clusters developed in this, right? So there are certain techniques like your k-means technique, fuzzy c-means technique, hierarchical clustering, dbscan clustering. So these are widely used clustering technique that you can use while developing, that you can use for designing the cluster for the given data set. Now, these are certain applications of clustering technique. You can apply it into agriculture, biology, physics, CS space, any domain you can apply clustering. You can apply the clustering to the same domain as similar to the supervision. The only difference is you are going to analyze the data. If the data is unlabeled, you are going to techniques. First one is your k-means, k-medioid, dbscan, hierarchical, fuzzy c-means. So these are some widely known techniques. Now let's start with the k-means technique. K-means is a simply iterative method, and it starts with the known value of k. We are going to supply the value of k, whether the value of k is 2, 3, 4, whatsoever is the value of k. Based on that, we are going to develop the cluster. If the value of k is 2, it means 2 clusters are developed at the end of the algorithm. If the value of k is 3, it means 3 clusters are developed or obtained at the end of the algorithm. Now, what is the first step? First step is to determine the centroid coordinate. You can select as per all, you can select any random coordinate. It's not like you have to select the first two or the last two or the middle two. You can select any elements, any data objects as the centroid object. Then the next step is to find out the distance of each object to the centroid, and then you have to group the object based on the minimum distance. So these are the three main steps of the k-means clustering. First step is to determine the value of k, which is already provided in the question. Next step is to find out the centroid coordinate, and then you have to determine the distance of each object to the centroid, and then you have to group the object based on the minimum distance. So this is the flow graph. You have to start with the number of the cluster k. If k is 2, it means 2 groups will be developed at the end of the algorithm. If k is 3, there are 3 clusters. You have to find out the centroid, distance of objects with respect to the centroid, and then grouping based on the minimum distance, the distance you have computed in the previous step. Right. Now consider this example. Suppose we have several objects, 4 type of medicines, and each object have 2 attributes or features as shown in the table. Our goal is to group these objects into the 2 groups. It means the value of k is given and the value of k is 2 here. So we have to group 2 group of medicines based on the 2 features right now, right? So we have medicine A, B, C, and D. So 1, and the value of medicine A is 1, 2, 4, 1, 1, 2, 1, 4, 3, 5, 4. So these are the objects that we are going to club, and we have to designate each data object into the 2 clusters because the given value of k is 2 here, right? So it's a plotting of those objects. So let's start. We have to select any object as a centroid. So let us suppose we are selecting C1 and C2. That is the first 2 objects. 1, 1 and 2, 1 I am selecting as a centroid. You can select any of the object. You can select AC, you can select AD, BC, CD. It's up to you. But in the equation, if the question is coming in the exam, I'll be providing the initial value of coordinates. Otherwise, the answer or the calculation will vary, right? So here we are selecting A and B, that is the objects 1, 1 and 2, 1 as the centroid objects, right? So we have selected 1 1 and 2 1. So centroid 1 is 1 1 and centroid 2 is 2 1. Next step is to find out the distance of all the objects with respect to the given centroid. So we have to calculate the distance between the cluster centroids, and in this example we are using Euclidean distance. So by default in the equation, if nothing is provided, so you have to calculate and you have to find out the distance of the object with respect to the centroid using the Euclidean distance only. Do not use Manhattan distance in k-means clustering, right? Keep this thing in your mind. If it is not provided in the equation, you have to, by default, you have to use the Euclidean distance matrix in order to find out the distance of objects with respect to the centroid. So these are our objects 1 1, 2 1, 4 3, 5 4, and our centroid is 1 1 and 2 1. So we have to compute the Euclidean distance. So what is the distance of 1 1 with 1 1? It is always 0. And when we are computing the distance of 2 1 with 1 1, it is computed as 1. Then we are going to compute the distance of 2 1 with the centroid 1, that is 1 1, it is 1. And then we are computing the distance of 2 1 with the centroid 2, it is again 0. And similarly we are going to find out the value of the d naught, that is the distance metric. यहाँ तक किसी को डाउट है कुछ, how we are computing the distance metric?
No, ma'am.
If you have any doubt, you can write it in the chat box. Otherwise, I can move ahead. Oh, supposedly no doubt, right?
मैम एक्सक्यूज मैम, एक डाउट है, ये डिस्टेंस वाला एक बार रिपीट करेंगे थोड़ा सा?
हाँ हाँ हाँ, आप मुझे पॉज कर लेना जहाँ पे भी आपको समझ में नहीं आया, अभिषेक, ठीक है?
ठीक है मैम, ठीक ठीक।
ठीक है, यहाँ पे देखो नीचे जो हमारी ये डिस्टेंस मैट्रिक्स बनी हुई है 1 1 2 1 4 3 5 3, राइट? ये हमारे
यस
इनिशियल
मैम।
डेटा ऑब्जेक्ट्स थे जो यहाँ पे गिवन थे 1 1 2
हाँ
1 4 3 5 4। हमने
यस
अपनी
मैम।
इनिशियल सेंट्रॉइड्स जो लिए थे, इनिशियल सेंट्रॉइड्स यू कैन सेलेक्ट रैंडम एनी टू डेटा ऑब्जेक्ट्स इफ द वैल्यू ऑफ के इज,
वो क्लियर है मैम, वो क्लियर है, वो क्लियर डिस्टेंस जो है वो।
हाँ, अब यूक्लिडियन डिस्टेंस फाइंड आउट करने की क्या इक्वेशन है?
अंडर रूट के अंदर x2 माइनस x1 का होल स्क्वायर प्लस y2 माइनस y1 का होल स्क्वायर।
हाँ हाँ ठीक है। अब 1 1 का डिस्टेंस मुझे निकालना है सेंट्रॉइड 1 से।
ठीक।
तो क्या होगा यूक्लिडियन डिस्टेंस ऑफ 1 1 विद द सेंट्रॉइड 1?
1 माइनस 1 0 यानी
0। सो डी नॉट
हाँ
में पहला एलिमेंट 0 है।
ठीक है मैम।
आप देखोगे ऊपर वाला एलिमेंट 0 है, ठीक है? देन आई हैव टू फाइंड आउट
ठीक
द
है।
डिस्टेंस ऑफ यूक्लिडियन डिस्टेंस ऑफ दिस a, that is 1 1 with respect to the centroid 2, that is 2 1. Again we have to find out the Euclidean distance of 1 1 with 2 1 and which is equals to 1. So 0 1 आ गया, ठीक है?
ठीक है ठीक है ठीक।
Similarly, we are going to find out the Euclidean distance of 2 1 with 1 1 and 2 1. जब हमने 2 1
ठीक
का
है मैम,
1
क्लियर
1
हो
से
गया,
निकाला, ठीक है, इसी तरह से
क्लियर
निकालेंगे।
हो गया। यस मैम, यस मैम, यस मैम।
Okay,
थैंक्स।
so this is how our D naught is formed, right? So each column in the distance matrix symbolizes the object. The first row of the distance matrix correspond to the distance of each object to the first centroid, and the second row is the distance of each object to the second centroid, right? मैंने यहाँ पे सॉल्व भी करके दिखाया। फॉर एग्जाम्पल डिस्टेंस ऑफ द मेडिसिन 4 3 टू द फर्स्ट एंड सेकंड सेंट्रॉइड, सो 4 minus 1 plus 3 minus 1 which is approximately equal to 3.61, and the distance of object 4 3 with respect to centroid 2 is 2.83. So this is mentioned in the matrix D naught. So this is our first step. First we have to find out the centroid and we have to compute the Euclidean distance of all the data objects with respect to the given centroid. So our distance matrix is formed, that is 0 1 1 0 3.61 2.83 5 and 4.24, right? Now our next step is to group the cluster based on the distance matrix. Our group 1, our cluster 1 is 1 1, and our cluster 2, that is group 2, is 2 1. Now we assign each object based on the minimum distance. Medicine A is assigned to group 1. Medicine A is assigned to group 1 because it is close to centroid 1. Medicine B is assigned to which cluster? Group 1 or group 2? It is close to which cluster?
ग्रुप 2।
It is close to which cluster?
ग्रुप 2।
Yeah, right. Similarly, medicine C can be assigned to which cluster? Group 1 or group 2? It is close to which one? Group 2 again? because the distance with group 2, that is the centroid 2, is 2.83, and the distance with the centroid 1 is 3.64. So 2.383 is lesser than the 3.61. So again, medicine C is assigned to group 2, and the final object, that is D is assigned to group 2 again. So at the first iteration, we have two groups, and in one group, which element is assigned? Only A, right? And in second group, which what are the elements assigned? Rest other elements, that is B, C, D, right? A is assigned to group 1 and B, C, D is assigned to group 2. This is the ending of our iteration 1. Again, we have to compute the new centroid in the next iteration, right? Group 1 has only one member, so the centroid will remain same. Our group contain only one element, that is 1 1, so the centroid will remain same. But now group 2 has three elements, that is B, C, D. So what would be the next centroid? Initially, after the one iteration, A is assigned to cluster 1, B, C, D is assigned to cluster 2. So in cluster 1, there is no change, there is no addition of the data elements. So centroid will remain same, that is 1 1. But in centroid 2 or in the cluster 2, there is an addition of the elements B, C, and D. So now we have three data elements instead of the one. So how we are going to compute the centroid of the cluster 2 or the, so it is the average of the elements, right? So 2 plus 4 plus 5 divided by 3, 1 plus 3 plus 4 divided by 3. So this is how new coordinates are formed. Now our coordinate 1 is 1 comma 1 and coordinate 2 is 11 by 3 comma 8 by 3. Clear to everyone how we are forming the next coordinates? Abhishek, is it clear to you? Clear how we are forming the next coordinates? Fine, assuming it's clear to you, right? Again, we have to find out the distances, that is the Euclidean distances of each and every data object with respect to the updated centroids. Our centroid 1 is 1 comma 1 and our centroid 2 is 11 by 3 and 8 by 3. So again, we are finding out the Euclidean distance of 1 1 with 1 1 is 0. That is, distance Euclidean distance of A with centroid 1 is 0, and Euclidean distance of A with centroid 2 is 3.14. Euclidean distance of B with centroid 1 is 1, and Euclidean distance of B with centroid 2 is 2.36. Similarly, Euclidean distance of C with centroid 1 is 3.61, and Euclidean distance of C with centroid 2 is 0.47. D with centroid 1 is 5 and D with centroid 2 is 5.1. Now, how many elements are there in group 1 now? Is there any addition or removal of the data elements from the cluster? Initially, cluster 1 contain only one element, that is A, and cluster 2 contains B, C, D. After the second iteration, is there any shuffling of the data elements from cluster 2 to cluster 1? See, data object 1A is closer to the centroid 1, so it will remain in the cluster 1 as it is. Now check for the data element B. It is now closer to cluster 1, that is the centroid 1. So now B moved to cluster 1. So A and B are the part of cluster 1. C and D are the part of cluster 2 because the distance of C and D is closer to centroid 2. So now at the end of the second iteration, we have two cluster. Cluster 1 contains A and B and cluster 2 contains C and D. So this is how the grouping of the data objects assigned to the different clusters. Again, we have to repeat the iteration. At what step we are going to stop the process of k-means clustering? The step where we'll be getting the same clusters in the last two iterations. Either it is provided in the exam, you have to perform two iterations or three iterations. And what is the stopping criteria of this algorithm? Once you'll start receiving the same cluster in the last two iterations, right? So again, we have to start the process. Now, what are the elements in the cluster 1? What are the elements in centroid 1 now? What are the elements in centroid 1 now?
Average of A and B.
Yes, it comprised of A and B, and the centroid 2 is the C and D. That is the average of A and B and the average of C and D. So again, we have to compute the new centroids. That is the average of A and B. So 1 plus 2 by 2, comma 1 plus 1 by 2, 4 plus 5 by 2, and 3 plus 4 by 2, right? So our updated centroids are 1.5 comma 1, 4.5 comma 3.5. Again, we have to find out the Euclidean distance of all the data objects, that is A, B, C, D, with respect to the centroids, and this is our distance matrix. So is there any shuffling of data elements in iteration 3 from cluster 1 to cluster 2 or cluster 2 to cluster 1? Is there any shuffling? Is there any movement of the data objects from cluster 1 to cluster 2 or cluster 2 to cluster 1? Hopefully not, because A is
AB
close to
in 1,
cluster 1, B is
CD in
again
2.
close to cluster 1, C is close to centroid 2, and D is close to centroid 2. So A and B are the part of cluster 1 and C and D are the part of cluster 2. It means we'll be receiving the same cluster data points as we received in the iteration 2. So this is the point where we are going to stop the process, and the end of the process, what we'll be getting two clusters. In cluster 1 there are two elements, that is A and B, and in cluster 2 we'll be getting two elements, that is C and D. So this is our final element. Medicine A belongs to group 1, medicine B belongs to group 1, medicine C belongs to group 2, and medicine D belongs to group 2, right? So here we have
मैम,
the, yes, yes,
हाँ
yes.
मैम, शफलिंग का मीनिंग समझ नहीं आया है, शफलिंग का।
Shuffling means is there any movement of the data elements, that is shuffle कर देना. जब आप songs को shuffle करते हो, so means randomly कुछ भी आ जाता है. Movement of the data elements, right?
जैसे मैम ग्रुप 1 में ए और बी आ रहा था और ग्रुप 2 में सी और डी आ रहा था,
हम्म.
तो ये शफलिंग कहलाएगी या नहीं कहलाएगा, समझ नहीं आया मतलब।
आप शफलिंग छोड़ो, आप बस ये सोचो कि मूवमेंट ऑफ द डेटा एलिमेंट्स, क्या बी से सी में कोई, आई मीन टू से क्लस्टर 1 से क्लस्टर 2 में कुछ गया और क्लस्टर 2 से क्लस्टर 1 में कुछ गया, दैट्स इट. आपने लास्ट स्टेप में इटरेशन 2 में यू विल बी गेटिंग टू डेटा एलिमेंट्स, टू ग्रुप्स विद द टू डेटा एलिमेंट्स. ग्रुप 1 में भी दो थे और ग्रुप 2 में भी दो थे, ए एंड बी, सी एंड डी. ठीक है. अब हम चेक करेंगे आफ्टर कंप्यूटिंग द ऑब्जेक्ट सेंट्रॉइड डिस्टेंसेस, इज देयर एनी मूवमेंट ऑफ द डेटा एलिमेंट्स फ्रॉम ग्रुप 1 टू ग्रुप 2 और ग्रुप 2 टू ग्रुप 1? नो,
ठीक,
राइट? सो
ठीक है,
दैट्स
नो
इट.
मैम, यहाँ इस लिस्ट
हाँ,
में नहीं है, हाँ।
हाँ, बस दैट्स इट. यू हैव टू जस्ट चेक कि इज देयर एनी मूवमेंट ऑफ द डेटा एलिमेंट्स फ्रॉम ग्रुप 1 टू ग्रुप 2 और ग्रुप 2 ग्रुप 1. दैट्स इट. नथिंग एल्स यू नीड टू बॉदर
ओके,
अबाउट, राइट?
ओके।
Yeah. Now, these are the data elements. You have to apply the k-means clustering on the data provided and considering the initial centroids at C1 and C2. Find out the answer at the end of the second iteration. Do this question and find out the answer at the end of the second iteration. I can ask any one of you to share the answer with me. The value of k is 2. The value of k is 2. Find out at the end of the second iteration what are the data elements in cluster 1 and what are the data elements in cluster 2. डन।
मैम
यस।
मैम डिस्टेंस मैट्रिक्स जो है ये 2/4 की बनेगी।
2/4 मीन्स आपके डेटा
जैसे
ऑब्जेक्ट्स ये
कि
है
करा
ना,
था 2/4।
ये हैं आपके डेटा ऑब्जेक्ट्स 185, 72,
हाँ
170, 56, 168, 60, 179, 68, जैसे पहले क्वेश्चन में किया था, तो वैसे ही तो बनेगी। आप 185 और 72 का डिस्टेंस निकालोगे पहले सेंट्रोइड 1 से सेंट्रोइड 2 से, वो ऊपर नीचे आ जाएगा। ऐसे ही 170, 56 का डिस्टेंस निकालोगे सेंट्रोइड 1 और सेंट्रोइड 2 से। सिमिलरली फिर रेस्ट ऑफ द एलिमेंट्स। सो आपकी रोज कितनी होंगी, रोज शुड बी 2, एंड आपकी
हाँ,
कॉलम्स कितने होंगे, कॉलम्स उतने होंगे जितने आपके डेटा एलिमेंट्स प्रोवाइडेड हैं।
ठीक ठीक है मैम,
ठीक है,
ठीक।
हाँ हाँ ठीक है।
ठीक है।
Any difficulty you are finding while solving this question? It's simple, the one we solved earlier. Just you have to find out the Euclidean distance of each and every data object with respect to the cluster 1 and cluster 2. If the distance is closer to cluster 1, you can keep it into the group 1. If the distance is closer to cluster 2, you can keep that element in the group 2. And based on the elements in the group 1 and group 2, you have to again find out the class centroids, that is centroid 1 and centroid 2. Centroid 1 is the average of all the data elements in the group 1, and centroid 2 is the average of all the data elements in group 2. And again you have to find out the Euclidean distance of each and every data object with respect to group 1 and group 2. And then you can check, is there any movement of the data elements from group 1 to group 2 or group 2 to group 1. And finally at the point where you will be getting the last two iterations producing the same kind of same cluster, in that case you're going to stop the process. Clear to everyone? Process is clear. Now I'll be moving to the hierarchical clustering technique now. No, hierarchical cluster technique is a kind of the tree-based clustering technique, and which is representing the data object in the form of the hierarchy, or you can say it is creating the clusters in the form of the tree. So hierarchical clustering techniques is of the two type: agglomerative clustering and divisive clustering. How many you have covered in MLDM? You covered both kind of clustering, agglomerative and divisive in MLDM, or
Yes,
only?
ma'am.
Okay.
ये दोनों हो गया, यस मैम।
ठीक है. So agglomerative hierarchical clustering, it uses the bottom up approach. It start with the individual data element in order to form its own cluster and iteratively merge cluster to generate the larger and the larger cluster. Now what is the difference in finding out the distance matrix? Which distance metric we are using in agglomerative? It's covered in your MLDM na? Now name which distance metric we are using to find out the distance of one data object with respect to the other. Are we using Euclidean distance? No answer. Why no answer?
मैम एक लिंकेज करके कुछ होता था, वो वो कह रहे हैं क्या आप?
हाँ हाँ हाँ
सिंगल
वही
सिंगल
सिंगल लिंकेज कंप्लीट
हाँ
लिंकेज एवरेज linkage centroid based
हाँ
method. So in
हाँ
hierarchical clustering we are not making use of the distance based matrices like your Euclidean distance or Manhattan distance for finding out the distance of that object with other matrices, right? So it's an example of your agglomerative. We are going to club the data objects based on the distance, like in this example A and B are merged, then D and C are merged, then after next iteration CD is merged, and at the end we will be getting a final data element, that is ABCDE. So this is also known as AGNES. Divisive is an opposite of the agglomerative clustering, where we have the all data elements is a group of one cluster, then we have to segregate those elements. After that AB formed, CDE formed, from the CDE D and E are segregated and C are segregated, and the end will be getting at the leaf node will be getting all the individual data elements. So divisive and agglomerative are opposite in approach. One is top down and another one is the bottom up. So proximity metrics. So these are the four proximity metrics that will be making use while finding out the distance: single linkage, complete linkage, average linkage, and centroid method. In single linkage, the distance between the two clusters is the shortest distance between the 2 points. Complete linkage is the distance between the two clusters is the longest distance between the 2 point. Average is the average of the data elements. Centroid is the center of the group of the objects and is used to determine the average distance between the cluster of the data objects. Now consider this example, right? At the first step, what is your first step? You have to find out the distance matrix. Let us suppose if the data objects are provided, the one we did in the previous question, like 1 1 2 1 3 1 4 1. What is your first step? First step is to find out the distance matrix. If it is not provided in the question, you can use any other distance matrix like your Manhattan, or you can say Euclidean, for finding out the distances of the object with respect. Otherwise, if it is provided in the question, you have to use the Euclidean, then you have to compute all the distances with respect to the using the Euclidean only, right? Now, so we are computing the distance of object to itself is always 0, which is mentioned here. And then distance of B with A, B with C, B with D, E, F, similarly C with A, B, D, E, F, and this is how we are computed the distance matrix. So this is the initial of agglomerative clustering route. Now, in this metric, we have to find out the smallest element. So at what position we'll be getting the smallest element? It is highlighted in the red, that is D and F. The merging point of D and F will be yielding the smallest distance amongst all, and that smallest distance is 0.50, which will be getting at the location D and F, right? So in this example, closest cluster between the shortest distance is 0.5. So the shortest distance will be getting at what? D and F. So which two cluster we are going to merge here? We are getting shortest distance, and that shortest distance is 0.50, and this 0.50 will be getting at F and D. So the point where we'll be getting the shortest distance, we are going to club those data objects. So in first step, which two data objects we are going to club? It's D and F, right? Based on the minimum distance present in this distance matrix, right? So this D and F is merged. What is your next step? Your next step is to find out the DF, this clubbed data objects with respect to the other data object, that is the distance of DF with A, distance of DF with B, distance of DF with C, distance of DF with E, right? So what is the distance of DF with A? What is the distance? If I'm using the single linkage approach, that is the smallest of the distance between the two, what is the distance of DF with A? How much is the distance of D with A? How much is the distance of D with A?
3.61.
Yeah, ठीक है. And the distance of F with A?
3.20.
So in single linkage, we'll be considering the distance with the minimum value, right? So while writing the distance matrix in the next iteration, so the distance of DF with A is 3.0 because it is the smallest. While developing or creating this distance matrix with the complete linkage, our answer could be 3.61, and in using the average, it is the average of the two. So this is how we update our distance matrix. Distance, all the distances are mentioned here, right? Only the distance with df, that is the club cluster, is in the question mark. How much is the distance of df with a, how much is the distance of df with b, df with c, and df with e, right? So as we are using the single linkage, so we'll be considering the smallest distance. Like in this example, minimum distance of DA and FA. So the minimum distance of DA and FA is 3.20. Similarly, while computing the distance of DF with B, the minimum of distance of DB with FE, that is 2.50. Similarly, while computing the distance of DF with C, we'll be considering the minimum of DC and FC, which is equal to 2.24. Now finding out the element or the distance of DF with F, it equals to 1 and 1.12. So the minimum one is 1. So this is how our distance matrix is updated. Clear to everyone? While updating the distance matrix, that is all the question marks here. DF to A, how much is the distance? It is 3.20. DF to B, the distance is 2.50. DF to C, the distance is 2.24. And DF to F, the distance, sorry, DF to E, the distance is 1. So this is how your distance matrix is updated. Now again, the next step is to find out the next minimum element present in the distance matrix. So your next minimum element is 0.71. At which location you will be getting it? A and B. So in next step, which two elements you are going to club? In the next step, which two elements you are going to club after DF? The elements are A and B. So again, we have to find out the distance of AB with C, the distance of AB with the clubbed data elements, that is DF, the distance of AB with the element E, and the one with the smallest value we are going to consider while updating the distance matrix, right? So this is our data elements. AB is merged, so we have to find out the AB, distance of AB with C, distance of AB with DF, distance of AB with E. So how much is the distance of AB with C? How much is the
Ma-
distance of AB with C?
5.66 if we consider the uh, complete linkage.
In the complete linkage, we'll be considering the highest value, and in the single linkage, we'll be considering the minimum value. So since we are solving this question using the single linkage, so we'll be considering smallest value, that is 4.59. Distance of C with AB. So distance of C with A is 5.66. Distance of C with B is 4.95. So while updating this matrix, what we will be mentioning here, AB to C is 4.95. Now how much is the distance of AB with DF? How much is the distance of AB with DF?
2.92.
2.92 or
92.
see, DF with AB, that is the D with A, D with B, F with A, and F with V. Now we have four combinations, right?
I don't get it.
DF with
I can
A,
check the web for.
DF with A, DF with B, that is DA, DB, FA, FB. So which one is the smallest element amongst all? DA, DB, FA, FB. कौन सा smallest है वहाँ पे? DA, DB, FA, FB. Here is our original matrix. DA is 3.61, DB is 2.92, FA is 3.20, and FB is 2.50. So which one is minimum? 2.50. So the distance of the club data element is 2.50, like this. Similarly, you have to compute the distance of AB with E, and the minimum one is 3.50. So this is your updated distance matrix, right? Again, you have to select the minimum smallest element, and that element is your 1, right? So you have to combine DF with E in the next iteration. Again, you have to find out the distance of DFE with AB, DFE with C. So how much is the distance of DFE with AB? DFE with C is 1.41, right? DFE with AB is 2.50, right? And rest other elements you can update like it. So is it clear how we'll be updating the matrix? Is it clear to you how we'll be updating the matrix?
मैम
Yes.
हाँ मैम ऑलमोस्ट क्लियर है, बाकी मैं
Hmm?
फिजिकली बात कर लूंगा। मैम डाउट ये था, जो जैसे सिंगल लिंकेज में आपने कहा था कि मिनिमम लेते हैं और कंप्लीट लिंकेज में मैक्सिमम लेते हैं,
हाँ
तो
हाँ
कोई
हाँ।
पर्टिकुलर रीजन है क्या मैम ऐसा करने का?
पर्टिकुलर रीजन नहीं है,
मतलब
बस डिस्टेंस फाइंड आउट करने की ये मेथडोलॉजीज हैं. सिंगल मीन्स यू आर कंसिडरिंग द स्मॉलेस्ट एलिमेंट, कंप्लीट मीन्स यू आर कंसिडरिंग द ग्रेटेस्ट एलिमेंट, राइट? दिस इज हाउ यू आर गोइंग टू फॉर्म द क्लस्टर, दैट्स इट, नथिंग एल्स. ये हायरार्की जनरेट करने के लिए, और कोई स्पेसिफिक रीजन नहीं है. ठीक
ठीक,
है, बस
थैंक्स
हमने
मैम।
ये किया, जो हम डिस्टेंस मैट्रिक्स जो हम के मीन्स में यूज करते थे, यूक्लिडियन और मैनहट्टन, यूक्लिडियन और मैनहट्टन की जगह हायरार्किकल में हम सिर्फ सिंगल, कंप्लीट, एवरेज और सेंट्रोइड बेस्ड मेथड ही लेते हैं टू अपडेट द डिस्टेंस मैट्रिक्स, राइट?
ठीक है, थैंक
So
यू।
at the last step, we have to find out the smallest element at DFEC combination, that is 1.41. So we have to combine those elements. Again, we have to find out the distances of all the data objects with respect to each other and the minimum we are going to consider. And this is our final data matrix. Finally, ABDEFC is combined at the final step. So in the beginning, we have 6 cluster, that is A, B, C, D, E, F. We merge D and F at the distance 0.50. Again, we merge cluster A and B at the distance 0.71. Then we are merging E with DF at the distance 1. Then we are merging DEF with C at the distance 1.41. And we merge cluster DEFC into AB at the distance 2.50. And the last cluster contains all the data objects, thus conclude the computation. This is how the dendrogram is created. Clear to everyone how the dendrogram is created? We just combine the two elements. DF is combined at 0.50. Then AB is combined at 0.71. Then DF to E is combined at DF to E is combined at 1. This is how your dendrogram is created. So if the question comes into exam, you have to create a dendrogram as well. So these are your final clusters. Initially DF combined it at AB, then E, and then C, and so on. Right? Now, solve this question using complete linkage. Solve this question using complete linkage. Smallest data element will be getting at the location 3, 5. So 3, 5 is 1. So how much is the distance of 3, 5 with 1 using the complete linkage? How much is the distance of 3? Once we are updating the distance metric, how much is the distance of 3, 5 with 1? The one with the maximum value, that is 11. How much is the distance of 3, 5 with 2? 3 with 2 is 7. 5 with 2 is 10. So the one with the maximum value will be considering. How much is the distance of 3, 5 with 4? 3 with 4? 9. Right? So you have to update the distance matrix with the maximum value. So this is how your distance matrix is corrected. At this step, which elements we are going to merge? At this step, initial step, we are merging the elements 3, 5. At the next step, which two elements we are going to merge after 3, 5? The one with the minimum value. And what minimum value will be getting in this distance matrix? That is 5. So 2 and 4 is combined. Right? So 2 and 4 are merged. Again, we have to compute the distance of 2, 4 with 3, 5. 2, 4 with 1. So this is how your distance, the one with the highest value, we are going to opt and update the distance matrix. And this is how your dendrogram is created using the complete linkage. And this is using the single linkage. Clear to everyone? Yes or no?
Yes, ma'am.
Okay. So, are your projects ready?
Yes,
Your
ma'am.
final.
Almost, ma'am.
Okay. So, do you have any free slot tomorrow?
Rather than your period or rather than your lecture
Ye-
after
Yes,
that,
yes. After that.
ma'am, it's quite difficult because we just have to like submit all other
Yeah. Yeah. Do
projects
you
and
have
all.
any free slot on Friday?
No, ma'am. Friday we have
Okay.
our vivas.
Okay. So in that case, we'll do one thing. You can show me your projects in online mode, right? But you have to submit the hard copies to me.
Okay, ma'am.
Okay.
Is tomorrow last date?
No, no. By Friday.
Okay, by Friday.
Yeah, yeah,
Okay.
yeah. Friday in the evening, I will evaluate your projects as you don't have any time on. I can evaluate in Thursday too in the evening if you are okay. 5:30 to 6:30, I can evaluate your projects. If you are ready, I can evaluate tomorrow, and if you are not ready, I can evaluate on the Friday as well. So tell me the date on which date you are comfortable.
Friday, ma'am.
Okay, okay. So Friday, I'm going to evaluate your projects in the online mode, but be ready with your hard copies. On Friday, you have to submit the hard copies in my cabin, right? Okay.
Yes, ma'am.
Okay, just submit your hard copies, and in tomorrow's lecture, I'm covering the DB scan technique and the one left, that is the divisive one. After that, I'll be sharing the clustering code on your lecture section that you can refer, and that's the ending of your lectures, right? क्लासिफिकेशन टेक्निक्स में कोड मैंने सिर्फ दो का कराया है, दैट इज नाइफ बेस और डिसीजन ट्री, और ईडीए कराया है, ईडीए अच्छे से करना। और इसमें मैं जितने का कोड करूंगी, कोड वही आएगा आपका एग्जाम में, उससे एक्स्ट्रा आपका कोई कोड नहीं आएगा। कोड के लिए सिर्फ वहां पे रेफर करना, जिस 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 टेक्निक का कोड होगा उससे एक्स्ट्रा मैं कोई कोड नहीं दूंगी, राइट? कोड बट क्लस्टरिंग का कोड मैं वहां पे आपके क्लासरूम पे पोस्ट कर दूंगी, दैट यू कैन रेफर ऑन। उसमें कुछ नहीं होगा, आपको सिर्फ अपना पैकेज लगाना है और डेटा देना, वो क्लस्टर करके दे देगा, नथिंग मच इज रिक्वायर्ड, राइट? सो आई विल बी शेयरिंग द क्लस्टरिंग techniques code on the classroom, and tomorrow I'm going to cover the rest, that is the db scan and some eda also, along with the divisive hierarchical clustering in tomorrow's lecture. And on Friday I'm going to evaluate your projects, final projects, 5:30 to 6:30 in online mode. But prior to that, you have to submit the hard copy of your project reports. Clear to everyone? Also have you submitted the solution to the assignment, the one which I posted last week? I've given you the
Yes,
deadline, you
Yes,
can
ma'am.
submit.
ma'am.
Okay, fine. Fine. So let me take your attendance and then you can leave. Any free slot today's, any free slot in the first half or the second half, so that I can mark in that duration your attendance. 9 to 5, any free slot?
10 to 11.
How, which one? 10 to 11.
10 to 11. Yes, ma'am.
And after 2 o'clock, because I was on leave na first half, so I can't take a lecture.
Other, after 2 to 3 also we have free slot.
Okay, okay. So I'll be updating in the 2 to 3 slot your attendance, this attendance,
Okay.
right? Yeah.
Okay.
Thank you.